So this set of notes is actually the 4.7 homework, which I've asked your class to do during class time. One thing I'm going to suggest is that anything that's an odd degree polynomial, make it a cubic, just because they're so much easier to graph. And all even degree polynomials, make them quartics. So number one's already a quartic, so I'm going to start by graphing the parent. Since I'm looking at these, this is just going to be shifted down 9 units, so I don't really need to show anything in quadrants 3 or 4, so I'm just going to go ahead and put my x-axis here. Nope, that's a lie. This is shifted down 9, so let's see. I don't want to do that. Let's see, 1, 2. I'm going to count by probably 3s here to make this a little easier for myself. So I will do this. I will put my x-axis here. Sometimes you have to be a little creative with these guys. I'm going to put my y-axis here. And x to the 4th power. So if I'm counting by 3s, that's not great for a 4th power because my first output after 1 is going to be 16, but I'll make it work. So 3, 6, 9, 12, 15, 18 is going to be here. So if I plug in a 1, I get out a 1. So it's going to be a little distorted looking. That's okay. I plug in a 2, I get out a 16, which is about here. And the same for my negative inputs. So this is the parent function. Okay, so this way I was able to graph all 5 points. Then, of course, my origin. Okay, and then if I graph the transformation, I want this same guy, but just shifted down 9 units. So I'm going to go down 3, 6, 9. And that's not a good pen. You'd think I would have tried these beforehand. Nope, not so much. Okay, and again, out 1, up 1. And again, I'm counting by 3s on the y-axis. Let's see, where was I? Okay, and then over to up 16. So that's going to be 3, 6, 9, 12, 15, and 16. So just the whole guy shifted down 9 units. So that's down 9. So I described it, and then I'm graphing. Yep. And again, this guy's going to look just a little distorted because of the units on the axes.